Hey guys, today for the review I have the KAIWEETS KM602. I received this multimeter from the KAIWEETS company to make a review. It's the KAIWEETS KM602 Smart Digital Multimeter. Before we dive in, I want to let you know I'll be giving away this multimeter. Stick around until the end to find out how you can enter. Let's start with the unboxing. It comes with a sturdy carrying case. There is a USB cable for charging the multimeter. There is a thermocouple for temperature readings. There are the probe leads. There is a multimeter. There is a plastic film on the display. You can remove it. It comes with a multilingual manual. The multimeter includes a durable plastic cover that helps protect it from accidental drops. The select and function buttons are on the left side of the multimeter. The flashlight and max-min buttons are the right side. Press and hold the flashlight button to turn on the flashlight. The power and charging port are at the top. This is the port you use to charge the multimeter. The current, COM, and input jacks are at the bottom. Remove the protective caps from the multimeter probe ends. Remove the protective caps from the probe leads. Press and hold the power button to turn on the multimeter. By default, it starts in auto measurement mode. This means you can measure AC/DC voltage, resistance, or continuity without pressing any additional buttons. Press the function button on the left side to switch to manual mode. The first option is to measure DC voltage. Press the select button to switch from DC to AC voltage. Press the function button again to cycle to the next mode, where you can measure resistance. The next mode detects continuity. The next mode measures millivolts. The next mode measures frequency. The next mode measures capacitance. The next mode tests a diode. The next mode measures temperature. The next mode measures current. The next mode detects non-contact AC voltage. When you press the function button again, it goes back to the auto mode. Now it's time to test this multimeter in action and evaluate its performance. The display shows how the probe leads should be connected. Insert the black probe into the COM jack. Insert the red probe into the input jack. Start by measuring the voltage of this AA battery. The voltage measures around 1.5 volts, as you'd expect from a brand new AA battery. Now it's time to measure the AC voltage. I've connected a power strip to the wall outlet and we'll be taking our reading from it. A reading of 118 volts is consistent with the typical voltage supplied by most US residential outlets. The next test is to measure this 330 ohm resistor. The meter reads approximately 327 ohms, which is within the expected range. The next test is to measure continuity. Since I know this alligator clip works, I should hear a beep. Hearing the beep confirms continuity. For the next set of tests, switch the multimeter to manual mode. Press the function button repeatedly until you reach frequency mode. The display reads around 60 Hz, which is the standard electrical frequency for household outlets in the United States. The next test is to measure capacitance of this 100 microfarad capacitor. Press the function button to switch to the capacitance mode. The display reads around 103 microfarad, which is within the expected range. Now let's move on to testing the N4148 fast switching diode. Press the function button to switch to the diode mode. The display shows roughly 0.6 volts, which is exactly what you'd expect when the component is forward biased. The next test is to measure the temperature of this ice water. Press the function button to switch to the temperature mode. For this step, switch over to the thermocouple. Plug the black connector into the COM jack, then insert the red connector into the input jack. The temperature currently is at 22 degrees Celsius and 72 degrees Fahrenheit. When I put the measurement junction in the ice water, the temperature drops to 2 degrees Celsius and 36 degrees Fahrenheit. The next test is to measure the current of this simple circuit. Press the function button to switch to the current mode. First, connect the black probe to the COM jack. Next, plug the red probe into the input jack. When measuring current, make sure you use the jack on the left side of the meter. The display reads about 20 milliamps, which is what you'd expect for the current flowing through a typical red LED. The next test is to detect non-contact AC voltage. Press the function button to switch to the NCV mode. I have an air filter connected to a wall outlet. The top of the meter is the NCV probe. When a strong electric field signal is detected, the display shows the letter H and the meter starts beeping very quickly. This is a great multimeter. The display is bright and easy to read. It covers all the standard multimeter functions like measuring voltage, resistance, and continuity, but it also goes a step further with less common features such as diode testing, temperature measurement, and capacitance testing. It has a rechargeable battery, so no need to buy a AA or 9-volt battery. The case is a thoughtful addition that helps protect your meter from everyday bumps and wear. It is fast and accurate. Now it's time to explain the giveaway. To enter, complete the form linked in the description. In 2 weeks, I will do a random draw and announce the winner. For full details of the giveaway, please refer to the description. No purchase necessary. Good luck! If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.